All right, I'm going to go ahead and get started. Welcome everybody to another Lean BYTES. For those of you who are new to Lean BYTES, because I know we have a few new team members, as well as we have some external people as well. Lean BYTES is a thing we do here at LT every 2 weeks, where somebody gets up and speaks about a topic for 16 minutes. 16 minutes to, leverage that BYTES, the BYTES joke. John does not like the BYTES joke. And so this is something that we do every couple of weeks. So you can expect us to continue doing these in the future. And today I'm going to be the one talking about JWT or JSON Web Token or JWT fundamentals. So we're going to talk about what are JWTs exactly, how do they work, why should you care about JWTs, where do I put them once I have one, and how do I debug them? And I'll also do a live demo with JSON Web Tokens as well. So obviously we only have 16 minutes. So my goal out of this talk is to give a basic understanding of JSON Web Tokens, what they are, how you should use them, why you should care about them, and where do you put them. I am not going to go deep into OAuth flows. So often with OAuth flows, you use JSON Web Tokens, but that will be a future Lean BYTES due to only having 16 minutes. So what is a JSON Web Token? If you Google that, you will come across this fancy definition where it talks about, hey, it's a standard that's based on, it's about securely sending data back and forth using a JSON object, and it's signed with a secret or a public and private key, which to me, this doesn't really say a whole lot. So I would rather just dive into how JSON Web Tokens work so you can get a better understanding. So there are three parts to a JSON Web Token: the header, the payload, and the signature. So those are the three pieces that you need to worry about. And JSON Web Tokens in general are base64 encoded. So those three pieces are base64 encoded, not encrypted, more than likely, although you can also encrypt JSON Web Tokens as well. So if you look at a JWT, you will see something like this, where you will have the first part. So you can see that part in red is the header. And then there's a period to separate, hey, this is the header from the payload. And then in that pink or purple color, you've got the payload there, and then another period, and then the blue right there is the signature. So those are the three parts of a JSON Web Token. So if I just take that header and we base64 decode it, again, this is just base64 encoded, so anybody can decode this, you will get back a JSON object that looks something like this. So the algorithm there, or the alg, is the algorithm. So this defines the signature, the algorithm that the signature used. So in this case, it was RSA SHA-256. The KID key is the key ID, and this is an optional field. So if you have multiple keys from your issuer, and we'll talk about that here in a little bit, then this is the thumbprint that identifies which key was used to sign your JSON Web Token. And then the type is the type of token this was. In this case, is an access token, so the AT plus JWT. You may also see JWT there as well as another type. So that is the header. When you take the payload and base64 decode it, you'll get something like this. Don't worry if you can't see that. We'll go through a live demo here in a little bit. But these contain all the different claims. So you have three different types of claims that are part of this payload. Registered, so these will be a lot of your 3-character claims, and they use 3 characters because JSON Web Token is supposed to be a small format. So they use 3 characters for the keys for all the registered ones. So you have like ISS for who the issuer is, AUD for audience, not before, saying, hey, this JSON Web Token is not valid before this time, or that number is the second since the epoch. And you've got a bunch of other ones like sub is like user ID and things like that. You also have public ones. So these would be typically more non-3-character ones. So these are ones that are kind of agreed upon as well. So scope and client ID are common ones there. And then you might also have private claims. So these would be things specific to your application. So like company ID, employee ID, maybe instead of roles, you have like an is admin flag or something like that. So those are the 3 different types of claims, but the claims tell you things about the user who's logged in. And then finally, you have the signature part of this. So this is really where the magic sauce of JSON Web Tokens lies, because this verifies that the payload has not been tampered with. Because obviously, being base64 encoded, you can just decode it, grab the contents, switch them. Like you could change like the user, the sub, so the user ID, and like increment by 1. I'll do a demo of that here in a second, or like flip the isAdmin to the true, something like that, and just re-encode it. But the signature is based on the contents of that JSON Web Token. So if you modify it, it would not be able to verify that signature, and then it would fail. So this is signed by the private using private key from the issuer, and then you can verify that with a public key as well. So why do you use JSON Web Tokens? So before JSON Web Tokens existed, we used cookies a lot of times for web applications. But the problem with cookies is they are stateful. So you got to check, hey, is this cookie still valid all the time? Whereas JSON Web Tokens are more self-contained and stateless, because you can say, as long as you have the public key, and make sure that everything is good to go. As mentioned, you can verify it with public key. You can use JSON Web Tokens with mobile apps and web apps. We're not going to go into what this flow means, but you can use something called the authorization code flow with Pixie for those. And you can also use it for machine-to-machine communication. So like an API to an API, a CLI to an API, whatever your case may be. You can also use it for where there's an end user with a web and mobile app, or for machine-to-machine communication. And for that, you'd probably use client credentials flow. So some common gotchas. Most JWTs are just encoded, not encrypted. But if it is encrypted, the header algorithm will tell you if it is. And because it's encoded, not encrypted, you should not put any sensitive data inside of a JSON Web Token, because anybody could, if they got a hold of that JSON Web Token and there's like a social security number on it, they could just decode that and get that right away. So that's another thing to be mindful of. And libraries will do a lot of this heavy lifting for you. So like doing validation, getting you new JSON Web Tokens when you're about to expire, that kind of stuff. So this was kind of a genesis of this talk, is because, and the origin of this talk is a lot of times libraries will do kind of all this stuff under the covers for you. So this is just kind of peeking below the covers a little bit to talk through how JSON Web Tokens work. But for instance, if you're using Okta with the Okta or with React, there's an Okta React package that will kind of take care of a lot of this stuff for you. You just pass it like the issuer or the client ID and a few other elements, and it'll do all the heavy lifting and validating and getting you new tokens and all that stuff for you. So just FYI, you do not have to do this all yourself. All right, let's say you have a JSON Web Token and you've got a React app or an Angular app or Vue app. Where do I put that exactly? So you can put them in one of two places. You can either put them in session storage in your browser or local storage. So the difference between these two is session storage is once you close the tab, the browser will automatically wipe those contents for you, whereas local storage will persist even after you close a tab. So even if you open a new tab, you get a new set of session storage. So that's also something to be mindful of. Session storage is a little bit more secure because it's automatically wiping those contents without you having to wipe that yourself, as opposed to local storage. So just kind of depends on your scenario. All right, let's get into a live demo here. I'm going to move Zoom out of the way because it is currently in the way. So I've got this locally running site here. I'm already logged in, and log out, log back in, so you can see this is all running locally. I'm just logging in as Alice. Chrome's going to tell me, hey, Alice isn't the most secure password. And I already know that, but it's just a local demo. So if I go to Chrome over here and go to the application tab, you can see there's local storage here and session storage. So it just depends on where you're storing this. In my case, I'm storing it in session storage. And then this output here may be different. So it may look a little bit different. I can bump this up a little bit too. So it might not store in this exact key in this exact format, but if you go look in your local and session storage, you should be able to find your JSON Web Token. I'm just going to go ahead and grab the access token and come over here to this site. So this is JWT.io. So this is a place where you can go to troubleshoot your JSON Web Tokens. It is run by Auth0, and they do say they don't record the tokens, but just something to be mindful of. In my case, it doesn't matter because this is just a local token. but I would probably not drop a production token in here, but this is just a good thing to demo. So you can see it breaks out the header, tells me what the header is. If I hover over this stuff, it'll say, hey, algorithm's the signature encryption algorithm, key ID, the type. So that's kind of nice. And then I can see what the different claims are on the payload. So not valid before. So this token is not valid before 11:54, which is when I just issued it. And then it expires at 12:54. So again, this is second since the epoch, so since January 1st, 1970. And then you can just look at all these different things. And obviously you could have custom claims here as well. But then you'll notice down here, it's saying, hey, verify the signature. And in my case, I plugged in the public key here. So if I scroll down, it'll say, hey, the signature is verified. So this is valid. But by default, this won't be here. So you might see invalid signature until you plug in your public key. But if I wanted to change some stuff here, let me go back to my application tab and grab this value. So just to prove to you that the signature really does what it should do. So if I do ATOA, I grabbed too much because it grabbed the whole thing, and really I just want to base64 decode this part here. So grab that, maybe. It's like auto highlighting for me. All right, so if I go ahead and grab that value here, what is ATOA? Is that not working? This is fun. I can pull an old one. ATOA is not referenced. It should just be baked into Chrome. Open up a new Chrome tab here. Well, I'm not sure why that's not working. Oh, wait, hold on. It's because still got the whole thing. Why did that not copy? Copy. ATOA. Paste.
Things are though not defined. Okay.
Yeah, I don't know why that's not working. So that should be baked in JavaScript. All right, well, you'll just have to take my word for it that when, if I took this value, took this payload and tried to base64 encode it, and like I tried to increment like sub to 818728, and then just drop this in here. So I think what changes here is this right there. So I just changed this from a 3 to a 4. You'll notice that says 818728. But you notice now it says invalid signature because that value is no longer valid. So because this claim is no longer valid, but if I flip that to a 3, again, flipping this back to a 7, you notice that the signature is verified. So that's showing an example of if I was tweaking this payload, this signature would no longer be valid. So that is JSON Web Tokens in action, doing a little live demo of changing the base64 encoding on the fly rather than using the browser. So that was fun. So just to give a summary here real quick, we went over just what JSON Web Tokens were, how they work, why you should care about them, and where you should put them. So like session storage or local storage when you're in a browser. Tool for viewing and debugging them with JWT.io. And in the future, we'll go over OAuth flows at a future Lean BYTES or another event that we have. I know we only have 2 minutes, but are there any questions or comments people have? Don't everybody speak up at once.
What is ATOA function supposed to do?
So it's supposed to base64 decode it
For JavaScript.
But I don't know why that doesn't work. I think it's ATO.
Yeah. I think it's A2B.
Is it? Did I have this wrong? ATOB? You're right. That's why that didn't work. Helps when you use the actual right function. Thank you. Live demos are fun. But anyway,
Mystery solved.
that makes a lot more sense. Makes me feel a lot better. I was just typoing. But again, pretty much what I was trying to demo there is just that the signature validation failed. There's a few people in the chats. Oh yeah, Matt Smith. It's ATOB instead of ATOA. Thanks, Matt.
Is there a situational recommendation for when to use session storage versus local storage?
I would say, do you want it to wipe every single time you close the tab or not?
Do we have a recommendation?
I would say use session storage for JSON Web Tokens because then you know that it's cleared out versus hanging out there forever. Say local storage might be more like preference stuff or things like that. That might be more durable.
Sounds like a sensible default.
It does indeed.
And most libraries will throw in session storage for you by default, depending on what library you're using.
Does Okta also have a tool to decode JWTs? Or just lost
I'm
it?
not aware of one.
Okay.
But this will do any JSON Web Token, not just
Right.
like auth zeros.
Yep.
JSON Web Tokens. So
It's like the only tool I've seen online for it. I just didn't know if there was a competing tool.
I'm sure there is, and obviously you can run like base64 encode and decode stuff locally too.
Mhm.
It's just a convenient tool for demos.
When we were working at Principal, that's basically what I had to do with the ISR.
Cool.
Cool. Any other questions? Otherwise, we are at time.
Well, since you introduced yourself, do you want to wrap up for yourself?
Yeah, I guess I'll wrap up for myself too. So in 2 weeks, we're going to have another Lean BYTES on you might need Docker if, and I believe Mr. Graff over here is going to be leading that effort with Alex McClure as well. So look for that in a couple of weeks and the details for that. And we'll also send out feedback forms after this as well, so we can gather feedback and you can pass along the feedback to me.
Please share and invite others as you hear topics that you'd like to think would be valuable for them and only take 16 minutes out of their day. Or
Yeah.
18 if we're, over a couple of minutes today.
And if somebody wants to give a Lean BYTES in the future, obviously just reach out to either me or post in the Lean BYTES channel on our internal Slack, however you want to do that. And we'll get you on the schedule.